Year 2, hope you're all right. So this lesson is for week 11, day 2, and it is all about to recognise and use the inverse operation between subtraction and addition. Sounds like a bit of a confusing learning objective, but all it is it's understanding that addition and subtraction are really closely linked. And so if you're adding two numbers together to make a larger number, you can also subtract the larger number from one of the smaller numbers and get the other smaller number. I'm just going to show you a really easy one. So 2 add 2 equals 4. We all know that. And then if we did the subtraction one, 4 take away 2 equals 2. So can you see we've used the same three numbers, but we've used them in an addition number sentence, but we've also used them in a subtraction number sentence. So we're going to use this strategy. It's a really clever method actually if you're thinking, oh gosh, I don't know how to do that. Really good to remember that you can use the inverse to sometimes check your learning, but also figure out some problems as well. So I've got this one here. These are missing number problems. Now, we did lots of work on missing number problems before all of this madness began, but it's really been quite a while since you've done missing number problems, and you might have forgotten the method, but hopefully it will all come flooding back to you once we've done a couple of these, and that's what you're going to be doing today in your learning. So I've got 36 add something equals 77. So what I'm going to do is I'm actually going to use the inverse operation. Inverse means sort of the opposite operation. This is an addition one here, but I'm going to use subtraction to find out my answer. Now, with subtraction, I always have the biggest number first. With addition, you're going to get the biggest number and you have the two smaller numbers. With subtraction, you always start with the biggest number. So I'm going to change this around. And I'm going to write 77 take away 36. And I know, because with my little number sentence down here, that the third number will be the same even if it's an addition one or a subtraction one. So this is exactly the same as finding out what this missing number problem is here. Now, the way I'm going to do this is I'm going to use, and sort of show you a different way, is a part-whole model. And it's explaining that two parts make a whole, okay? So I've got a whole here, and I've got the two parts which make the whole. So I'm going to put my big number in here, 77. I'm going to put the number that I know in here, and then I need to find out what this number is going to be. So I'm going to use my trusty lines and crosses again. I do love a line and cross. And I'm going to make 77 with my lines and crosses. So 10, 20, 30, 40, 50, 60, 70. And then 7 ones, 1, 2, 3, 4, 5, 6, 7. Okay? Now, remember I'm subtracting. So I need to take away 36 from my 77. Okay? So I'm going to take away 3 10s, 10, 20, 30, and 6 ones. 1, 2, 3, 4, 5, 6. And I'm left with 10, 20, 30, 40, 41. Now, I can now use the inverse to double check. I can do 36 add 41, and hopefully I'm going to get to 77. So 36, 2, 3, 4, 5, 6, 41, 1, 2, 3, 4, 10, 20, 30, 40, 50, 60, 70, 71, 72, 73, 74, 75, 76, 77. Done. So can you see that this was a missing number sentence for addition? We turned it into subtraction, and then we checked it using the inverse by adding the two small numbers together, and we got our total. Okay? So now when we come to this one, 73 take away something equals 42, we don't use the inverse. Okay? We carry on subtracting because we've got the big number and the small number, okay? So it's only really when you have a missing number problem which has addition that you use the inverse. For this one, it's the same using a part-whole model, but you don't need to worry about adding it together. So 73 take away something equals 42. I'm going to draw my part-whole model again. 73, because that's the big number, that's the whole number. And then I'm going to figure out which two part numbers are going to make my whole. I know 42, and I'm going to do exactly the same thing. I'm going to write out 7 tens, 3, 4, 5, 6, 7, 3 ones. Can you see this? Yes, you can. My wonky piece of paper. And then I'm going to cross off 1, 2, 3, 4 tens. I've done that, and cross off 2 ones. And my answer is 10, 20, 30, 31. I can now use the inverse to double check that 42 add 31 makes 73. So I'll add those two together. 1, 2, 3, 42, add 31, 10, 20, 30, 40, 50, 60, 70, 71, 72, 73. Done. So you can use the inverse to check, but when it is a missing number problem and it's a subtraction one, you stay subtracting. When it is a missing number problem and it's an addition one, you change it to subtraction. So pretty much always use subtraction, okay? And then use the inverse to just double check that you've got the answer correct. Now if, I'm just going to do a little example down here. Imagine if you had 38 add something equals 77. And I did a part-whole model. Hope you can see this, yeah. 77, 38. My inverse would be 77 take away 38. Now, I've noticed a problem. I've noticed that I can't take away 8 ones from 7 ones. So I need to do a bit of exchanging. This is where it can get a little bit confusing. So that's why you really need to look at the numbers when you do this part-whole model. So I'm going to draw out 77, 10, 20, 30, 40, 50, 60, 70, 1, 2, 3, 4, 5, 6, 7. And then remember with the exchanging, I need to cross off a 10 and borrow 10 crosses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've exchanged. I can now borrow 8 ones because I've got plenty more ones. So I'm going to now work it out as normal, like I've done with these. So 38, I can cross off 3 tens and I can cross off 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to work out my answer by counting it 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. And you'll find that 38 add 39 makes 77. Okay? Right, thank you very much. I hope that's helped and enjoy your learning. Bye.